Well, this is our perimeter and area review too. So we're going to start with the formulas we've discussed. This first formula is the area formula for a parallelogram. And since squares are parallelograms and rectangles are parallelograms, we can use this for not only the parallelogram, but we can use it for square, rectangle, and as well. So the next formula you see is the formula for a triangle. And this triangle formula can also be written like this, because taking 1/2 of the base times height is the same as taking the base times height and dividing it into 2. Finally, we haven't talked about this much, but wanted to go over this briefly. This is the formula for a trapezoid. And a trapezoid just has to have 2 parallel side lengths. So the other 2 sides can do something differently. They don't have to be parallel. This is kind of maybe a trapezoid you've seen before. This is called an isosceles trapezoid because these 2 lines have the same measurement, yet they're not parallel. So the perimeter is one-dimensional. We're just trying to find a length. And so we add all of the side measurements. For area, it's 2-dimensional. So we're trying to find how many square units are inside. So we need to multiply 2 measurements. The perimeter is talking about the outside all the way around, and the area is talking about the inside. How many square units? So let's begin. Let's go ahead and look at this first one. Now this is an example of what I want to show you where sometimes they give us more measurements than we need. We're trying to find the distance around the outside. So we don't really care about the height when we're doing perimeter. So in order to find the perimeter, we just need all the measurements on the outside. So I see a 16 and I see a 10. And that's very common for students to stop there, but we have to remember that this side above it is also part of the outside, and this side is also another part. So we need to go all the way around. So the perimeter would equal 42. And notice the unit of measure, feet, and we're just talking about a line. That's like having 16 feet plus 10 feet plus 16 feet plus 10 feet. We're trying to put all of those lines together as one. Next, when we talk about area, we have the same figure. We notice all these same measurements, the outside, the 16 and the 10. However, we want to know how many square units are on the inside. So we need the base and we need the height, but we don't need to know this side measurement. So we're going to write area, A for area, and we're going to use base times height. That's the formula we need. This is the base, and this is the height. So we're going to replace that formula, base with 16, and we're going to replace the height with 8. And then when we multiply 16 times 8, we get 128, and we have to say feet squared, because we're talking about how many square units are on the inside. All right, so now let's go to the triangle. When we look at this, again, sometimes we have measurements we don't need. We just need the outside dimensions. So we're going to write perimeter, P for perimeter, and we see 16, we see 15, and then we see 11. And so the perimeter of this also happens to be 42. At this time they're going to measure is kilometers. Now I wanted to talk to you about this figure. Oftentimes in a triangle, you're going to see the height written inside the figure, but this is an obtuse triangle, and so they often show the height outside the triangle. They're just pointing out that this is the height from the bottom of the base to the very highest point of the triangle, or thinking about it as the height of the triangle down towards the base. So this is the height of the triangle. It might not look like it, but we're going to call this the height, and we're going to call this still the base. So we need area. The formula for this is 1/2 times base times height, or base times height divided by 2. So if you use this first version, we have 1/2 times 18 times 7.5, or 7 5/10. If you use the other version, we have 18 times 7 5/10 divided by 2. So please use your calculator and prove that both of these will yield the same result. If you used your calculator in the fraction key, then you came up with 67 1/2, and that's how many centimeter squares are on the inside. If you decided to use this version, then your calculator probably said 67 5/10, that's centimeters squared. All right, so this next situation, since we've only gone over this briefly, this is a trapezoid. And the trapezoid formula is very similar to the formula for a triangle. But a triangle just has one base and comes up to a point. The trapezoid has two bases. It has this length and it has this length, which are different. So we have to account for the fact that they're different. So the formula for a trapezoid looks like this. It's area equals 1/2, like the triangle, but we have to add the first base and the second base together to get the average of them, times the height. So instead of having just base, it's base 1 plus base 2. And here's what they're talking about, the base. This is one base, this is the second base. So they often label this as base 1 and base 2. And the height, again, from the very top to the bottom, is the height. So we're just going to insert these, or substitute these dimensions, and see what we get. So the area of this, 1/2 is part of the formula. Base 1 is 12. Base 2 is 8. And the height is 9. Now, if you recall, when we've worked with order of operations, it says that we need to do the parentheses first. So we're going to work on the parentheses first. So we now have area equals 1/2 times 20 times 9. So 1/2 of 20, if I work on this first, is 10. And we still have 10 times 9. 10 times 9 would be 90 feet squared. So now let's complete our last challenge problem. They ask us to find the height given the area. Usually we're asked to find the area and we're given the height and a base, or a length and a width. But this time they give us the area and they give us what looks like the base, and we're asked to find the height. So I see the word area, I see the word height, and I also see that this is parallelogram. So I'm going to write the formula, which is area equals base times height. Now, just like we substitute normally the base and height, this time they've given me the area, which is 80 inches. They've also given the base. So I'm going to replace b with 10, but we don't know the height. So if I look at this, this is an algebraic equation that we've solved before. I can either write it as 10h equals 80, or I can leave it as is. Either way, we can solve it by building our wall. I want to isolate h, and side by side, these two are side by side, so that means multiply. So I'm going to do the opposite. I'm going to divide by 10 on both sides. And we get h equals 8. We could also have done the same thing here. We always start on the side where the variable is to know what to undo. And so this would have been 8 equals h. Either way, we have the same answer. And now we want to look back at our unit of measure. So what we just found is the height is 8 inches. Thanks for listening and have a great day.